All right, 6.4 is proportional reasoning. When we talked just a moment ago about ratios, ratios can be compared, can be written as a fraction or with a colon between them. We read them as A to B. The part to whole or part to part are the two ways we can describe them. So one example in describing them is something like this, where we have 15 students in the class and 7 of them make an A. So we can compare 7 to 15, which would be the students who make A's compared to the whole class, or 7 compared to 8, which would be A's compared to not A's. So taking a look at this first example, we were told that the ratio of boys to girls is actually 2 to 3. So while we don't necessarily really have 2 boys and 3 girls, that is a ratio that can compare. For every 2 boys, we have 3 girls. So it is legit and appropriate to sort of describe this as boys compared to boys, sort of like plus girls down here on bottom. So in some way, we're taking the boys' value, which was 2, compared to the 2 plus 3, which is the boys and girls combined. So we do get the 2 out of 5. So that is an appropriate operation and an appropriate way to think about that. We can do this the other way around as well. We can talk about a certain number of the class being girls. So this is 3 out of 7, or 3/7 of the class are girls. Then what is the ratio of boys to girls? So right now I've got 3 out of 7. So the 3 is the girls. What is the 7? The total, which is something like girls plus boys, right? So if this is girls plus boys, and we already know that the girls is the 3 part of this ratio, what would boys have to be? 4. So once I sort of have identified that the boys is the 4 component of this ratio description, then I can answer the question that's actually being asked, which says I want to know what the boy to girl ratio is. And that would actually be 4, because that's the boys, to the 3, which is girls. Do you have a question? Yeah.
So does it matter, like, do you care if they give it as a fraction if we do with the colon?
It doesn't matter. You can use the colon if you prefer, especially on a problem like this. When we're actually doing some kind of operation with them, writing it in fraction form is just going to be natural and make a lot of sense. But if you write it in semicolon form here, that's fine too. It won't hurt anything.
And do you want us to show, like, work like that, like 3 and 4 and, like, 4?
On these are very straightforward. So if you're seeing that without that notation, that's fine. I'm not going to expect you to write that down. But just because you're seeing it doesn't mean that everybody in the class right now is. So I want to make sure everybody's seeing where we're getting our numbers from. So that's why I'm writing it down. Okay? All right. Okay, so the other part in this section then that we're actually moving into is the whole idea of a proportion. A proportion is simply a statement that 2 ratios are equal. For example, A over B equals C over D. So this is where, like, writing it as a ratio in fraction form becomes very useful, and the semicolon or the colon form is not quite as helpful in this particular point. At this particular point, writing it as an equation is what we want to deal with. So we're going to write them in fractions. There are 3 theorems related to proportions, and they're all very useful. So the first theorem, and they're all on the same screen up here. The first theorem says that if I have a proportion, A over B equals C over D, this is a proportion if and only if AD equals BC. So what happened to get from the first equation with the fractions to the second equation without them? It's cross multiplication, right? I mean, that's what happened. So we've got something going on like this. All right, the second one says that if I have the A over B equals C over D, and you'll notice there's lots of disclaimers about denominators not being 0. I mean, we see that throughout this particular problem. And I have a feeling that there's probably one missing there on that one too. This one should say A, C, and D. Otherwise, it's not going to work. They all have to be not 0. But if I have this fraction set up like this proportion A over B equals C over D, this will be true if and only if B over A equals D over C. What have they done? What's the comparison? They did the reciprocals, right? They just flipped the fractions upside down. Okay? Now, if you're not sure, like, why would that have to be true, if you think about the cross multiplication here, won't you get the AD equals BC? Even if you flip them? Yeah, you will. So this definitely has to work just like the first one did, because when I do the cross multiplication, I still get the AD equals BC. Okay? How about the third one? What did they do between this one and this one? Okay, which ones specifically got switched?
C and D.
C and B. They switched this diagonal, right? These two switched locations. And you might think, well, like, why would I do that? Well, when you're working with a particular word problem anyway, you often will do it without even thinking you did anything that was different than somebody else. You just set up the proportion differently. The comparison you made was a different order. Now, but think about if you take this equation right here, if I cross multiply, what happens? I get the same thing I did before. So from the perspective or from the standpoint of the cross multiplication, these all result in the same thing. So they should all make sense. Not only that, but there was nothing special about switching the B and the C. Could I switch A and D? Sure could. Wouldn't hurt anything, right? There's a lot of manipulations that I could do. Could I switch the B and the C and then do the reciprocal? I could. Because if I take these right here, like they switched the B and the C, and I flip them upside down, I still end up with AD equals BC. So that any of these sort of reciprocals, as long as I do to both sides, or switching a diagonal, they're all legit operations. All right. Let's stop there.